Hi, boys and girls. Today we are starting lesson 1 of chapter 20. So it's the last chapter in our book, but you know how we've jumped around a lot. So turn to page 497 in your module 10 through 20 book, and we are going to work through this together. Okay. So yesterday we talked about lines and angles and how we're going to see them in our different polygons. So the first thing, or our job today, is going to be to identify and classify polygons. So there we go, that's better. Identify means we can name them, we know what they are. And classify them means we can put them in groups based on their attributes. This word right here, attributes. Big word, a word that we're going to use a lot because we are very smart. And that just means characteristics. What are some things we know about those polygons that will help us put them into groups? Okay, so let's read this. It says, many of the figures found in art, nature, and science are familiar. Means we've seen them before. We know about them. They are familiar. Group these polygons based on 2 or more features or attributes that they have in common or characteristics. So this is up to you. You may have an idea of how you want to place these in groups, and it may be different than the way that I'm thinking about putting them in groups, and that's fine. Now, one way we can classify things is using a Venn diagram, kind of like we see right here. You may think of just 2 main groups. You may have 3 groups. Again, this is up to you. So, one way that you can do it is look at the amount of sides they have. These polygons have 3 sides. We call them triangles. These polygons have 4 sides, and we call them quadrilaterals. We're going to talk about them later. This has more than 3 or 4 sides. Okay? You could also look at their angles like we talked about yesterday. This figure and this figure, these quadrilaterals have all right angles. These might have some, but not all of them. So it's really going to vary depending on how you want to classify these. All right, so I think I'm going to classify mine as more than 4 sides and less than 4 sides. And I'm just going to list them. You could make a Venn diagram if you wanted to, or a table. So I'm going to draw those figures. So this one has less than 4 sides. So I'm going to draw it right here. These lines here on these triangles help you know that this side is equivalent to this side. That's what that means. This figure also has 3 sides. Do you see there's no lines here? That means that none of those sides have the same length. Okay? Right here. And I'm going to put less than or equal to 4 sides. No, you know what? Let's do equal or more than. Okay. So this square, which has 4 right angles and 4 equal sides, has equal or more than 4 sides. This is another triangle that has less than 4 sides. This triangle, which has 3 equivalent sides, is less. This is a quadrilateral. Might not be something that you have a name for, but any 4-sided figure is called a quadrilateral. Here's our rectangle. This side is equal to this side. This side is equal to that side. That's why it has different amounts. And it has 4 right angles. And then we have a 1, 2, 3, 4, 5, 6-sided figure, which we call a hexagon. And this hexagon has 6 equal sides. So we're going to put it here with our more than. That is just one example of how you could have classified these polygons. All right, let's turn the page. Mr. Berger and his class are looking at the polygons shown. So they're looking at this polygon. It has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 sides. Record the attributes of different polygons in the table. So, complete the column for the figure that has 7 vertices. Now we know because this is the one we're looking at. It has 7 vertices and 1, 2, 3, 4, 5, 6, 7 angles. Vertices, remember, are where 2 points come together. And number of sides, also 7. Name of the polygon. You may not know this name, but it's called a heptagon. A heptagon. All right, next we have a nonagon. Another word you might not be as familiar with. A nonagon has 9 sides, 9 angles, and 9 vertices. So you may think, just like it says here, nonagon is a polygon with 9 sides. Really, I always just kind of draw and make lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. Anything you want to draw with 9 sides is considered a nonagon, as long as those sides are straight. Okay? So, now we can pick 2 more. So, let's do one we haven't talked about. Let's do a 5-sided figure. That's called a pentagon. And it has 5 sides, 5 angles, and 5 vertices. Another one we could do, let's do an octagon. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides, angles, and vertices. What do you notice here about the attributes of each polygon? Okay, for each polygon, I'm noticing the sides, angles, and vertices are the same. All right, let's turn to the next page. Number 2, Mr. Berger drew these polygons on a whiteboard. Now the word congruent means equal angle measures or equal side lengths. And a regular polygon means it has all sides that are equal or congruent and all angles. So what do you notice about the attributes of group 1? You might notice that all the sides seem to be the same length. And the angles. This angle looks like that angle, that angle, that angle. Those we know are all right angles. What do we notice about group 2? I'm noticing that sides and angles are different. This is obtuse, this is acute. Same over there. Describe both groups of polygons using the words congruent and regular. So something you would say is figures in group 1 have congruent sides and angles. They are regular polygons. Group 2 has non-regular polygons that don't have congruent or equal angles and sides. Alright, so I want you guys to continue working, complete your homework for this, and do your best.